In this video, I'd like to talk about strategy, the number one differentiator between those who score really well on the GRE and those who don't. And specifically, we're going to tackle the main question, the number one question I hear from my students. My guess is it's a question or concern you yourself have. And if you're new to the GRE, if you're just starting on your own journey, I guarantee you it's an issue that you are going to encounter as well. Hi, my name is Brett Etheridge, founder of Dominate the GRE, and for over a decade now, I've been empowering hundreds of students just like you from all over the world to dramatically increase their GRE scores and get into the graduate programs and business schools of their choice. Now, I made a pretty bold claim, right? I talked about the importance of strategy in terms of elevating your ability to score high on the GRE. And it's absolutely true, it's crucial, it's that separator, it's that differentiator when you think about the components of doing well on the test. Now, I'm going to tell you a quick story here. I want you to understand kind of how I came to this understanding, why I believe it to be so fundamentally important, and it's really shaped the way I think about the GRE and my philosophy on teaching it. When I was in graduate school myself, I went to the University of Denver. I went to the Graduate School of International Studies, one of the premier international relations schools in the world, founded by Madeleine Albright's father. Dr. Condoleezza Rice went there, and it was a great, great school. I'll tell you why I chose it. I'd like to say it's because it was so prestigious and so well regarded in the field I wanted to study. The truth of the matter is, one, they gave me a really, really nice scholarship, so that definitely helped my decision making. I had a very high GRE score, and that definitely factored into the scholarship that they gave me. And the second reason is, you see some pictures here, I liked to ski. And so I saw it as a great opportunity to get a good education and ski pretty much every weekend, which was a phenomenal opportunity. Here's me with my wife, and you see a picture. I was there when the school won the hockey championship, actually in back-to-back years. So it was a phenomenal experience. But I was looking for a part-time job, and I actually applied to be a GRE instructor for a leading GRE test prep company. They were advertising, they were hiring instructors in the area, and so I said, hey, it's a good way to make some extra money, kind of to pay the rent, pay the bills while I'm a full-time grad student. So I went and I applied. And I remember the application process. I was given a test, a quiz, right? Part of the application was they wanted to make sure I could actually do the stuff, that I actually did know the GRE and the GMAT. I also teach the GMAT. And so they gave me this quiz, and they locked me in a room, and they said, don't come out until you've answered all these questions. And so I started going through, and some of them were easy, some of them were a little challenging. I was having no problem with really any of them until I got to a particularly challenging question. I wasn't quite sure what to do. Right here you see the question on the board. Where do I begin? I was looking at this question, I was like, what do I do, where do I begin? And this thought went through my mind. It said, uh-oh, if I don't get this right, I have a feeling I've got to get them all right if they're going to hire me as an instructor. If I don't get it right, I'm in trouble, right? And you may be experiencing the same thing sometimes on the GRE, right? You see a question, you're like, I need to get this right because I want a high GRE score. And the second thought that went through my mind was, I need to figure this out, right? I bet there is a way that I can still figure out how to solve this, even though I don't necessarily remember how to begin, how to do it the traditional way. And so I thought a little bit outside the box. I applied what I later came to kind of coin as non-traditional strategies, these strategies on how to beat the test. And without even knowing really what I was doing, I applied some of my own kind of future strategies to this problem, and lo and behold, I got the right answer. And kind of went on and got the job and had a blast, teaching for that company before I launched my own Dominate Test Prep, Dominate the GRE, and Dominate the GMAT. But I applied that understanding to my philosophy, and the reality is this, guys. The GRE, we've already talked about this, is a means to an end. At the end of the day, your job, your objective is to get right answers. Does that make sense? And so it's like too often we try to do problems in the traditional way, whereas really what we need to do is get right answers at all costs. And that is where strategy comes in. This is the second in a multi-part series, a free video series on GRE mastery. In the first video, we got very practical with content. I taught you motion problems. We talked about the success triad, and we looked at content. And then I hinted at the fact that strategy was also important. And I talked about how this is a beatable test, right? Oh, by the way, if you haven't watched that video, definitely go back and check it out. Thank you for all of the feedback. We've gotten an outpouring of comments and questions. I've received a ton of email. It seems like that video, hit you right where you are. I had one student email me and say, I've never been able to do distance rate problems before. You made it so clear and so easy for me. So I'm glad that helped you. I had another student, she wrote me an email and she said, I wish you had been my high school algebra teacher. Like, I would have done a lot better. So I appreciate that as well. So definitely, again, go back and watch that if you haven't watched that. In this video, we're going to be talking about more about strategy. And if you remember, I talked about Pablo and how really there is hope. This is a beatable test. Pablo came to this experience very weak in math. He admitted that he had a terrible math background, and yet he was able to boost his score, his GRE quant score, by 9 points, which is a huge improvement. And he wrote me after the fact and he said, Brett, the biggest thing that I took away from your course was strategy, right? The tricks and the strategies and the tips that you taught to help me get right answers more efficiently, more quickly. And that's what we're going to be covering in this video, and specifically addressing the number one question I get. All too often, you see a question pop up on your computer screen and you think to yourself, where do I begin, right? I mean, think back to the last video. My guess is everything I talked about made sense in terms of how I taught you how to do motion problems, distance, rate, time problems. But then what happens is students say, it makes sense when you do it, but then when I'm trying to do it on my own, or when I'm sitting down doing practice problems, or if I'm taking a practice test and a question pops up on my screen, where do I begin? And these strategies are not only going to help you get right answers more effectively, more efficiently, get unstuck on harder problems, kind of like me when I was applying for that job interview, but it's also going to give you that starting point. So what we're going to do is we're going to look at kind of their criteria. What I do is I like to think about it as having a Pavlovian response, right? That's how I teach it to my students. A Pavlovian response that says, the question pops up on the screen, I know what category to put that in. I know what type of problem I'm looking at. I know the criterion that I'm looking at. It matches these criterion, so I immediately know what strategy to employ. Does that make sense? So I'm going to give you the criterion so you know exactly what to be looking for and which question types are good candidates for which strategies. And then you will immediately know I'm giving you the starting point. Literally, boom, I see it's this type of question, or this type of question, or this type of question, boom, I know what strategy to employ. And then I'm going to teach you some of these strategies in this video as well. So I hope you're excited. I hope you're feeling empowered already. Are you ready to dive in? All right, let's take a closer look at strategy number one, criterion number one. But first, let me show you a sample question. In the sample question, you have a ball that's dropped 192 inches above level ground, and after the third bounce, it rises to a height of 24 inches. If the height to which the ball rises after each bounce is always the same fraction of the height reached on its previous bounce, what is this fraction? And then you have the answer choices. Now, this question may look familiar to you if you've actually already watched my free session. If you haven't done so yet, you can go, you see where to click on my website, dominathegre.com. You can get that free session. But what I want to do is I want to set the stage using this question as an example and thinking about the criteria, because what do you notice about the answer choices, right? The answer choices are what? All numbers, right? So the very first criteria that we're going to look at is if you see a question like this pop up on your computer screen where the answer choices are all numbers, it says answers equal numbers, right? If the answer choices are all numbers like you see here, that's the Pavlovian response that says, here's what I'm going to do. The strategy is to work backwards, right? That is the strategy. Now, again, I teach the working backwards strategy ad nauseum in my free session, so definitely check that out. And I even walked through an example using this strategy in video number one in this series. So I'm not going to reteach you this strategy here in this lesson. I simply want to set it up that if you see a question like this on your screen, and in fact, let's get very clear, right? Not only are the answers all numbers, but on the GRE, we're talking about discrete problem-solving questions that are multiple choice, right? Multiple choice. Sometimes you're going to have numeric entry questions where you have to actually provide the answer. Does that make sense? not a good candidate for working backwards because you don't have the answer choices to work backwards from. And in fact, let me summarize the strategy. If you're seeing this video for the first time, you haven't watched any of those previous lessons, the idea is simply, looking at the question again, the answer is one of those 5 answer choices. And so the temptation is to make our high school algebra teacher proud of us, right? To set up equations and solve for x and find the answer. But that's not always the most valuable way of getting the right answer on the GRE. Instead, what we can do is we can take those answer choices and kind of plug them back in and see if they work. So there's no room for error there. One of those answer choices actually does work. It's either going to bounce up to the height of 1/2 of its previous height. And then you kind of test that, and it either works or it doesn't work. And then you try like a third. You just try the different answer choices until you see which one works. And there's some kind of rhyme or reason to how to apply the strategy. Again, I'm not going to go over that too much in this particular video. But here's the thought I want you to have as we set the stage for the rest of this video. Question pops up on your computer screen. Boom. I recognize answer choice A, it's problem solving, it's a multiple choice question. Answer choices are all numbers. Ding, 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 Pavlovian response, I am going to work backwards. Rather than set up a traditional algebraic equation, I'm just going to kind of take those answer choices, plug them back in, and work backwards. Does that make sense? So that's the first strategy. I know we're not going into too much detail here, but I hope the idea is starting to make sense. And now you're probably wondering, well, what kind of other categories of questions are there? What other criteria might I encounter? And the next and potentially even more valuable strategy comes for questions that involve variables. Questions that involve variables. This is a very simple criteria, and it's a very populous criterion, meaning there's a lot of question types on the GRE that you are going to encounter that involve variables. Not only, by the way, on traditional discrete quantitative, discrete problem-solving questions, but also on quantitative comparison questions as well. So this is actually a slightly more versatile strategy because you're going to see variables in multiple places throughout the GRE. And anytime you see variables, Brett, when do I use this strategy? Anytime, every time, all the time that you see variables, it is a good candidate for a strategy called making up numbers. Take a look at this example. Now, before I even start to solve this question, let me ask you, is it a good candidate for making up numbers? Well, I'll give you a hint. A, at the top of the page, I've told you it's a good candidate for the variable strategy, right? The second thing is I'm clearly using it as an example for this strategy. So I've kind of given away the farm here. But why is it a good candidate? Because you see variables. It's very simple, right? A question like this pops up, you see variables in the question, you see it in the answer choices. Your response should be, I am going to make up numbers for this question. And that's really the idea, right? We want to take otherwise challenging, otherwise difficult questions and make them a lot easier. What makes a question like this difficult? The fact that it contains so many variables, and you may not be super strong at algebra right now, and that's okay, because here's what we can do. We can make up numbers for those variables, and it takes an otherwise esoteric question and makes it very concrete. In other words, if I give you the exact same question that has real numbers in it, instead of variables in it, it becomes a super easy question. And we can do that on problem solving, we can do that on quantitative comparisons. Quantitative comparisons work a little bit differently. I'm going to illustrate this example, which is obviously a problem solving question, but definitely check out our lessons on quantitative comparisons because the way you deal with variables on quantitative comparisons is a little bit different simply because quantitative comparisons work a little bit differently, but the idea is still the same, that you want to make up numbers to test kind of the relative size of the two quantities, the two columns. But here let's take a closer look at this example so I can illustrate exactly what I mean and how to apply this strategy. So in this question it says that Lois has X dollars more than Jim has. And right off the bat, I mean the problem's already annoying, right? That's what makes the GRE annoying, that's what makes algebra annoying. Why does Lois have X dollars more than Jim? Why not just like $5 more than Jim? And that's exactly the point. We want to make this problem easier by making up numbers for these variables, taking it from the esoteric and making it concrete, which in turn makes the question a lot easier, right? So we see the variables in the question, we see the variables in the answer choices, and we're going to say, forget that. You know, it's a good candidate for making up numbers. Let's go ahead and do that. So Lois has X dollars more than Jim has, and together they have a total of Y dollars. Which of the following represents the number of dollars that Jim has? And so your Pavlovian response says, I'm going to make up numbers, and it gives you that starting point, right? You literally on your scratch paper start by writing X equals, Y equals, right? If you're feeling stuck, this gets you unstuck. If you're not sure where to begin, this gives you that starting point. Now let me give you this caveat. If you're really good at algebra, or you look at a question like this and you immediately know how to proceed in a traditional way, go for it. I'm not telling you you always have to use the strategies I'm teaching in this video. I'm not telling you you always have to make up numbers. Some students are just really, really good at algebra. But for most of you watching this video, even if you are good at algebra, and I'm good at algebra, but I still find it easier to get a right answer on a question like this faster and more efficiently by making up numbers, no matter how good I may be at algebra. And so for a lot of you, if you're looking at this question, you literally just don't know how to do it. I'm going to teach you how to do it very, very easily. But even if you do, don't shy away from learning the strategies because they still may help you on even harder questions than this. Although this is a fairly challenging question according to the GRE, and it may give you that starting point or help you get unstuck. So with that said, let's dive in, right? So we're going to let X equal something. How many dollars more than Jim do you want to say that Lois has? I already kind of mentioned 5, so let's just go with 5, right? So 5 more dollars than Jim has. Now, in the videos in my course where I teach these strategies, I do go into a little bit more detail and I give you some rules, and I'll give them quickly here as well. You know, you want to avoid 0, 1, or numbers in the problem. And there are some reasons for that, but you know, for example, you don't want to say Lois has $0 more than Jim has. Haha, like that's not very helpful. You know, same thing with $1 more than Jim has. Now on quantitative comparisons, those aren't the rules. We have different rules for making up numbers for variables on quantitative comparisons. But for the purpose of this question, you know, we're going to avoid 0, 1 numbers in the question. So there's no reason that X can't equal 5. So if X is 5, that means Lois has $5 more than Jim has. Well, how many dollars does Jim have, and how many dollars does Lois have? So, and in this question, we can't really arbitrarily make up a number for Y because Y is dependent on kind of this interplay between J and L, right? So we know that that Lois is going to have 5 more dollars than Jim, but there's a big difference between if Jim has $10 and that makes Lois have $25, right? That will determine what Y is. Does it make sense? In other words, if I let Jim have $10, sorry, not 25, $15, $5 more, right? So Jim has $10. If Jim has $10 and Lois has then $15 because she has $5 more, then collectively they have $25, which becomes Y. Does that make sense? Because which of the following represents, and together they have Y dollars. So Y is going to now be 25. So I couldn't just arbitrarily make up a number for Y because it's dependent on really what I let Jim equal. So in that sense, there's actually like a third variable, J. What is Jim's dollars going to equal? If I had let Jim have $20, then Lois would have 25, and in that case, Y would be 45. Right? So Y equals 45 in that case, but I'm not going to work with those numbers. So I'm going to go with the ones that we originally did. So Jim has $10, Lois then has $15, so Y equals $25 together, and the question is, which of the following represents the number of dollars Jim has? Well, we kind of made up that for Jim, but Jim equals 10. That is the actual answer to the question. The actual answer to the question is, answer, $10. That's how much Jim has. But that's not what the answer choices look like. So the next step in the process is to say, oh, okay, well now I've got to take my values and plug them into the answer choices and see which one also equals 10. Does it make sense? And so we'll start with answer choice A, and answer choice A says, y minus x, so 25 minus 5 divided by 2. So that's 20 divided by 2, which equals 10. Hey, look at that. Answer choice A does equal 10, which is exactly what it's supposed to equal according to the question, so I need go no further. The correct answer is answer choice A. Now, we got a little lucky that the correct answer was answer choice A. If it turned out not to work out, then I would just keep testing answer choices until I find the one that matches my actual answer. But do you see how much easier this question becomes? So that's the strategy. You see the criteria for when to do it, and then now you see how to apply it. And I hope this is like a breath of fresh air for you, saying, wow, that does make sense to me. That does work. That does give me a starting point and also a way to get a right answer a lot more easily. So what do you think? Making up numbers. Pretty cool, isn't it? Hopefully you're feeling more confident already. And the reality is that between those two strategies alone, this is worth its weight in gold. It's literally worth a ton more right answers for you on test day, provided that you recognize when to use the strategies, and then now you know how to apply them. It's just a matter of you getting out there and practicing. But we're only halfway through. You guys curious what the next couple criterion are and the next couple of strategies? The third one that I want to talk to you guys about and introduce you to, it's a little bit less specific in terms of criteria that I can give you. In other words, working backwards, very simple. Multiple choice, and you see answer choices that are all numbers. Boom, you work backwards. You see variables, boom, you make up numbers. This third one is for questions that are hard or annoying. Like, what does that even mean? What it means is that it's your cue to think a little bit abstractly, a little bit creativity, a little bit more creatively. Now, unlike these first two strategies that are more science than art, in other words, it's very, very kind of mechanical. The criteria are very clear. The methodology, especially the way I teach it in my course videos, get very nuanced, like boom, boom, here's how you do it. Step 1, step 2, step 3, leaves very little wiggle room. It's foolproof. It's literally like, there's absolutely no reason you shouldn't be able to apply those strategies and get right answers. This third one is more of a mindset. It's this mindset that says, if I see hard or challenging or annoying questions that I don't immediately know how to do, I still think about my story about being there in the interview for the test prep company. I still have to get a right answer. And so your job is also to think a little bit creatively, get a right answer. And so the strategy is what I call my famous WBNI strategy. And this stands for wouldn't it be nice if. Wouldn't it be nice if? Guys, I've been in the industry a long time. I mentioned I taught for a leading test prep company. I've attended conferences. I've got friends in kind of competitor companies. I read books. I read blogs. Like, I'm familiar with what's going on out there. I don't know anybody else who is teaching this strategy, or at least conceptualizing it this way. And here's how I like to think about it. It's basically asking yourself, what don't I like about this question? And how can I make it a little bit easier for myself? And by the way, it's kind of an umbrella, in a certain extent, it's like an umbrella strategy for the others. And what I mean by that is, if you see a hard question, like the bouncy ball question, what don't I like about this question? I don't like the fact that I'm not very good at algebra and don't know how to set up an algebraic equation, so wouldn't it be nice if I could just work backwards? Does that make sense? This is the logic. Wouldn't it be nice if I didn't have to set up an algebraic equation, but could still get the right answer? What don't I like about this question we just looked at? Well, I don't like the fact that Jim and Lois have X numbers of dollars and Y number of dollars together. I don't like the fact that it has variables in it. Wouldn't it be nice if it didn't? Wouldn't it be nice if I could just make up numbers for those variables and work the problem that way? So it's an overarching strategy, but it also can stand alone, meaning sometimes there are questions that you can just kind of outthink and make an easier version of the harder problem, as you see here. So here's our sample question, and it's obviously from quantitative comparisons. It's a sample quantitative comparison question, and that's perfectly acceptable. You can also apply the WBNI strategy on traditional discrete problem-solving questions as well. But the idea is very, very simple. We don't like certain aspects of this problem, and we want to make an easier version of the problem to quote-unquote get at the underlying math concept or principle being tested, right? So what don't we like about this question? Well, obviously we have two quantities, and we don't have a question stem here. A lot of times, if this is your first time looking at quantitative comparisons, a lot of times they'll give you some additional information kind of at the top, above the quantities. But we're simply trying to compare these two quantities, and quantity A is the sum of odd integers from 1 to 199. And quantity B is the sum of the even integers from 2 to 198, which is larger. And what don't we like about this question? Well, we don't like the fact that there are so many integers. And clearly, the test makers aren't wanting us to add up all of those integers. Even with a calculator, you don't want to sit there and say, okay, 1 plus 3 plus 5 plus 7, that'll just take way too long. And if you remember, well, if you haven't taken my course, you may not have heard me say this before, but the overriding kind of principle with quantitative comparisons is compare, don't calculate. So compare, don't calculate, right? Don't calc. So, and I'm not here to teach you specifically how to do quantitative comparisons, but wouldn't it be nice if strategy comes in, because we need to ask ourselves, okay, we don't like the fact that there are so many integers. How can I make an easier version of the same problem? And the truth of the matter is that all I need to do is get at the underlying concept being tested. And in theory, it's like, okay, well, we start with a lower number, like 1 compared to 2, and then we're adding up to something a little bit higher, like 9 instead of 8, but the 2's bigger than the 1, but the 9's less than the 8, so how does it all work out? Well, let's make an easier version. What if instead of 1 to 199, we could just do something simpler, like 1 to 9, 1 plus 3 plus 5 plus 7 plus 9. Is that more manageable? Is that more doable? And wouldn't that essentially be the same thing on a smaller scale? In other words, what's annoying about this problem is that they made it such a big scale. But what if instead it had been 1 to 9 and then 2 to 8? So let's compare that to, 2 plus 4 plus 6 plus 8. Now, the key with this strategy, and this is where it's a little bit more art than science, and you have to kind of make sure you're paying attention, is you need to maintain the integrity of the original problem. So I can't go completely outside the scope of what the problem is trying to get at, but I've respected it, haven't I? I've still started with 1. In the second example, I've started with 2. I've still gone up by odd numbers and even numbers accordingly. I've stopped kind of at the 9 digit. I've stopped at the 8 digit. So far things are looking pretty good. And then now I can very easily compare them, can't I? And so the first quantity, column A quantity, kind of our abridged version of it, adds up to 4, 9, 25, right? And the second set, kind of our refined quantity B, only adds up to 2, 4, 6, 8, adds up to 20, doesn't it? So which quantity is greater? 25 is greater than 20, and we can more easily see that. Another thing that we see is that the first quantity is going to contain 5 terms, whereas the second quantity is only going to contain 4 terms. If you extrapolate that out, the underlying mathematical principle is that we will always have kind of an extra number in that quantity A. And so even if, we're adding 11 and 13, it doesn't matter if we actually do go all the way up to 199. There's always going to be one extra term compared to, if we add up to 198. So we'll always make quantity A bigger. So even if you missed the underlying mathematical principle going on, or didn't know how to manipulate it the way they want you to manipulate it and so forth, we can work with easier numbers, easier variations to get at the fact that quantity A is greater all the time no matter what. So guys, this is a direct application of the wouldn't it be nice if strategy executed. Wouldn't it be nice if? My students love this strategy. My guess is you're kind of blown away. This is totally new to you. You might be sitting there grinning because you see how powerful this is. You see how this can result in more right answers for you on test day. This mindset, I think, my guess is you're just like, your mind is just opening to looking at the GRE in a new way. This idea of it being a means to an end and getting right answers at all costs and looking at questions like you just looked at, and ordinarily you might not have known what to do, but can we make an easier version of an otherwise hard or annoying question? And the answer is absolutely. And you saw how easy that last question became once we think outside the box a little bit. Word of caution for you engineers. A lot of times I have engineer students and they're like, how come I'm struggling with the quantitative section? I'm so good at math. And I'm like, because you're thinking so linearly, like you're so locked into the traditional ways, right? Engineers tend to think that way. And I try to get them to think a little bit more creatively, a little bit outside the box with some of these non-traditional approaches, and especially the WBNI strategy kind of falls into that category. So stretch yourself a little bit as you're studying for the GRE. Just kind of keep that in mind. Oh yeah, just as a reminder, this is a good candidate for both problem solving and quantitative comparisons, as we just saw. So we're almost there, right? Final strategy, final criteria comes in the form of figures. Figures. Pavlovian response. You see a geometry question. You see a figure pop up on your screen. What do we do with that? Now, let me say something about figures. Figures on the GRE are assumed not to be drawn to scale unless otherwise indicated. So we need to do some things with figures to put them in a position to work to our advantage. Does that make sense? And so they're assumed not necessarily drawn to scale, and one of a couple things is going to happen, right? A question's going to pop up on your screen, and it's either going to contain a figure, it's just obvious there's just a figure there, right? Or a geometry question that clearly should contain a figure, but one isn't given, is given to you. And so what's the strategy? The strategy is, first and foremost, draw a figure if none is given. Always start there. Always use your scratch paper. He or she who uses the most scratch paper wins. Draw a figure if it's not, and the key is to draw it to scale. Because if a figure is not assumed drawn to scale, we want to draw it to scale. We want to kind of redraw a figure that's maybe not drawn to scale so that we can eyeball a right answer. Brent, are you kidding me? Like, you want me to literally just kind of approximate, guesstimate, eyeball a right answer? Yes and no. I want you to learn geometry. We talked about you do need content. There are some questions that involve figures that you absolutely have to do the traditional geometric way. You just have to know the math. I get that. Coordinate geometry, like there are certain things that you just have to know how to do, but on some questions, we can use the figures to our advantage and still get a right answer even if we don't know how to do the underlying math. Pretty crazy, bold statement, isn't it? Don't believe me? Take a look at this example. So obviously this is a good candidate for the strategy that we're talking about because there's clearly a figure here. Right, in the circle below, PQ is parallel to diameter OR. So I would be drawing this on my scratch paper, kind of redrawing it on my scratch paper, indicating that those things are parallel. And OR has a length of 18, right? So OR has a length of 18. What is the length of minor arc PQ? So they're wanting to know this kind of red arc right there from P to Q. Now you may be looking at this and you have no clue what to do. That's okay. Even if you do look at this and you are good at geometry and you know how to do the geometry, I still want you to pay attention to this criteria and this strategy because it may help you on other types of questions as well. And here's the reality. I actually hope you fall into the camp of people who don't know how to do this because I want you to stretch yourself. How can you still get a right answer at all costs? And in fact, feel free, press pause. See if you can pretend you were in the interview room like I was and you knew you had to get this right, but you weren't quite sure how to do it the traditional way, but you wanted to get the job. Or you're sitting on the GRE and you want to get a right answer, even if you don't know how. What would you do? How would you think creatively? And I already gave you the strategy, right? The strategy says you can eyeball in some cases, right? Now, is this figure drawn to scale? Well, I said we assume it's not, but it doesn't mean it's not. And in fact, as long as there's nothing that kind of violates any sort of, rules of geometry or physics, or whatever, there's no reason to believe this figure is not drawn to scale. It looks like a circle. It's clearly called a circle, so it is a circle. This angle does look like about 35 degrees. How do you know? I don't know. We'll hold a piece of paper up to your, crease a piece of paper, right? Take the corner of your piece of paper, that's 90 degrees. Kind of crease it, that becomes 45 degrees, right? Because that's what bisects a 90-degree angle. And then you can kind of like do that again and say, okay, well this is, 15, 30, 45. So that 35 looks pretty darn accurate, and there's no reason to believe it's not. OR and PQ look parallel. So we're going to go with this as a figure that is drawn to scale. And once it is, can we eyeball it? If I put a gun, and so here's the strategy applied, right? Obviously, you may want to learn how to do the traditional math. I teach that in my course. We have angles that are, you have two parallel lines cut by a transverse, so that means that's 35 degrees as well. You have an interior angle, it's called, or an inscribed angle creates an arc length that's twice as long as the inscribed angle, and so that would make that arc length OP 70, and that makes QR 70, and then that makes PQ 40 degrees because we have to add up to 180 degrees for a semicircle, and then we can apply that and use that to find the arc length and so forth. That's not what we want to do. We want to actually get a right answer even if we didn't know how to do the underlying math. And the key is to recognize they have given us a key. It's like a map, right? If you're trying to follow a map, what's at the bottom of a map? It's a key, like this length represents 500 miles. Does that make sense? And so if you wanted to know how long it would take to drive from New York to San Francisco, you can hold this little key up and just kind of guess how far it is from New York to San Francisco. We have the same thing here, right? They have told us that that length, OR, is 18. So I really, literally would want you to hold a piece of your scratch paper up to your computer screen and say, okay, how many PQs are going to fit inside OR? Does that make sense? So you put a little mark, a tick mark on your piece of paper and says, okay, this is one PQ, right? Here's another PQ. Here's another PQ. Hey, about 3 of them fit in there. That means if somebody put a gun to my head and forced me to guess, I would say that PQ is about 6. Does it make sense? And you can get very specific because the figure is drawn to scale. You can know literally the PQ is about 6. So what does that make the arc? A little bit bigger than 6, just a little bit bigger than 6. So now when we look at the answer choices, guys, which answer is that? Well, if pi is about 3.14, answer choice A is looking pretty good, isn't it? 2 times, something a little bit bigger than 3 is going to be a little bit bigger than 6, which is exactly what we would guess if we were forced to guess using the eyeball technique. Does that make sense? And, maybe answer choice B is slightly in the running because it's maybe kind of close, although it's a little bit closer to 7. It's kind of closer to 7 than it is to 6. But 9 is or C is closer to 9, a little bit bigger than 9. That's way too big. It's not half as big as OR. And then the rest of the answer choices get even bigger. So at worst, you've improved your guessing odds. At best, you actually literally get the right answer because of the eyeball technique. And it's unbelievable how often this can work to your advantage on the test. The bigger picture understanding I want you to have is outthink the test. Get right answers at all costs. If you can't figure out a problem the traditional way, I want you to think about what I've taught you in this video and realize you can still get a right answer. Don't get flustered, don't get scared, don't freak out. Start to think a little bit creatively, and this strategy gives you that ability. So there you have it. The 4 major criteria and the strategies on how to apply them. I hope you see how empowering this can be. I want you to visualize for a second. Kind of close your eyes and just picture yourself on test day. A question pops up on your computer screen. You don't freak out. You immediately are able to kind of recognize it, know what bucket to put it in, kind of what are we looking at? Are we quantitative comparisons? Are we problem solving? Do we have variables? Do we have answer choices that are all numbers? Are we working with figures? And then you immediately know the strategies on how to apply it. Now, if you're watching this video, you probably fall into one of three categories. First, you may be brand new to the GRE. If you are, glad to have you along for the journey. Right? And if you fall into that category, you absolutely need to start here. These provide a solid foundation upon which you can learn the rest of the content you need for the GRE. I'll learn some other strategies and shortcuts as well, certainly, that I teach in my courses. But this is the crucial place for you to start and build that solid foundation. Now, you might fall into a second category where you've maybe already taken the GRE, or you've been studying for a while and you're just trying to boost your score. You're trying to get to that next level, get those few extra crucial points on the quantitative section. We spent really this whole video talking about the quant section. And these strategies are for you as well. You may have even seen some of these before, maybe thought about some of these before, but ultimately it's about execution. Because just because you know kind of in theory how to do something, being able to adapt these strategies to different variations of questions and being able to execute them more quickly and more accurately is going to be huge for you. So practice them, revisit these videos, whatever you need to do to get better at these strategies. And you may fall even into a third category of student, which is you're actually a really good test taker, you're doing very well on the GRE, and your goal is top tier score, top 10 business school, top 10 PhD program. You're looking into crack 163, crack 165, get into the upper 160s. These strategies are for you as well. Because even if you're really good at math, as I talked about, it's not always still the best way of attacking the problems. Just because you may know how to do something the traditional way, time management becomes important on the GRE. These strategies can help you solve questions a little bit more quickly sometimes. And so, sometimes it's a matter of swallowing your pride and not always doing it the traditional way and applying these strategies as well. As with everything, it comes back to practice, right? I want you to think about what we've done to this point, thinking back to the last video. We have that success triad on the GRE. Content, we've tackled a lot of content already in these videos. We've tackled content in the last video with motion problems, but that's only part of the puzzle, isn't it? Then we looked at strategy, and we spent this video talking about, strategy ad nauseum. But ultimately, it comes down to practice and execution, and that's exactly what we're going to talk about in the next video in this series. So definitely look forward to that. Check your inbox for links to watch the next video in this series. We're going to tackle practice, but I'm also going to look at, we're going to talk about time management, because time management is a crucial component, not just of practicing in general. I'm not just going to give you some resources on how to practice. We're going to get very tangible, very specific, and give you some time management tricks and strategies as well, because ultimately, it's like thinking back to my kite surfing, right, where I talked about in the last video. You're equipped with how to do this stuff now, but when you get out and try to do it on your own, you may fall flat on your face the very first time. So use the community, use these resources, rewatch this video as many times as you need to. Post your comments and questions in the area below. Email me personally, reach out. We want to help you get through executing on these strategies. And with that, that's actually what I want to hear from you at this point. I want to know what in this video, which strategy was most interesting to you? Which one do you think is going to be most helpful to you as you think about dominating the GRE? Which one was new to you? Which one had you never heard about before? Maybe put another way, which strategy do you still have some questions about? You can type those in the chat area as well. So I want to hear your comments. I want to read your questions. I will be answering them and responding to them personally, because it is my job to empower you to dominate the GRE. So look forward to seeing you again in the next video. I hope you found this inspiring, empowering. Answer that question, which of these strategies was most helpful? And I'll see you on the other side to continue empowering you to dominate the GRE.